Hello. So let's discuss one example of Carnot cycle. That is 10-6 from our book. So it says there, consider a steady flow Carnot cycle with water as working fluid. The maximum and minimum temperatures in the cycles are 350 degrees Celsius and 60 degrees Celsius. The quality of water is 0.891 at the beginning of heat rejection process and 0.1 at the end. Show the cycle on a TS diagram relative to the saturation line and determine letter A, the thermal efficiency, letter B, the pressure at the turbine inlet, letter C, the net work output. And of course, in the book, here's are the answer. So we have here the given, the high temperature or the maximum temperature, I call that TH, is 350 degrees Celsius. The minimum, I call that TL, 60 degrees Celsius. Okay, later on, I will, let's notate that this is X3. That is the quality of water at the beginning of heat rejection, and X4, the quality of water at the end of the heat rejection. So, the first thing that we will do is to have a schematic diagram. So, you have to write what are the devices involved in Carnot cycle. So, you have the boiler, you have the turbine, you have the condenser, and you have the compressor. So it's like that. So I call this point 1 or state 1, state 2, 3, and 4. Okay. And I will also draw the TS diagram. The TS diagram, TS. And here's the saturation line. Okay. Now, I don't know. I'm not sure if the point 2 is superheated or saturated. Let's just say it's superheated somewhere here. And since here's the condenser 3 and 4, okay, this is where the heat rejection happens, and the heat rejection is here. Okay, so at the end or at the beginning of heat rejection is 0.1, so it means it is a wet mixture because it has a quality that is 0.1. Okay. Oh, no, sorry. It should be 0.891. So maybe it's here. And the 0.1 is here. So I would say that the TS diagram could be like this. Okay. What I'm sure is that okay, it's something like this. Now, point 1 is here. This is point 1, 2. This is the boiler. This is the boiler. This is the turbine, the expansion 2 to 3. Then 3 to 4, it's the condenser. This is the heat rejection. Okay. 4. Now that we have drawn the TS diagram and the schematic diagram, we could now answer the problem or the unknowns. First is the thermal efficiency. The thermal efficiency for Carnot cycle is this one. The formula is this. You have 1 minus TL, or the low and high. This equation was derived. I will not derive in this lecture because this is derived in term 1. But this is the derived equation for the Carnot cycle. So we must note that this temperature 1 and 2, okay, it's the same. That is TH, and this one is the TL. Okay, take note, it should be in absolute temperature. This is not in absolute. You should convert this Celsius into absolute to answer the efficiency. The efficiency now would be 1 minus low is 60. Of course, you have to convert that into Kelvin. So plus 273 divided by 350 plus 273. The efficiency that you could compute would be 0.4655. Of course, you must multiply 100%. So the efficiency now would be 46.5499. Take note, I rounded off here so that this is the whole set of numbers. So they have now the efficiency that is 45.55%. Now let's answer the pressure at the inlet, turbine inlet. Where's turbine? Here's the turbine. Here, this is the turbine. The inlet is this one. So we are talking about state 2. So say state 2. So at state 2, we have, ano ba yung mga properties dyan na given? So unknown yung P2, pressure 2. Ano yung ibang properties? Dapat meron kang dalawang properties para makuha yung ibang properties ng water. So in this case, meron kang anong temperature sa 2, yung TH, that is the maximum, 350. So you have T2, yan yung 350 degrees Celsius. Of course, hinahanap natin yung P2. Kaya lang, paano natin hahanapin yan? Hindi natin alam yung ibang property. At the same time, we are not sure kung yan ay superheated nga ba talaga o wet mixture. Ito hindi natin sigurado ito. Ano pa yung mga pwede nating makita? Kung titignan mo, yung S2 at S3 ay parehas. So, pwede kong sabihin S2 equals S3. Okay? Now, yan lang ang given natin. Pwede tayong mag-proceed sa state 3. Kasi makukuha natin yung S3. So, state 3. Yan. So, para makuha yung ano yung nasa state 3? Yung state 3 meron kang X3. X3 yan ay 0.891. Ibig sabihin, kapag meron kang quality between 0 to 1, 0 meaning saturated liquid, 1 meaning saturated vapor, in between that, you have a what you call a wet mixture. Okay? Kaya nandito siya. Nasa wet region. Yan. So, ano pang meron ka? Ang temperature mo sa point 3, T3 ay yung TL. Yan yun, 60. Okay? Kapag meron kang dalawang properties, kaya alam mo na wet mixture siya, alam mo yung quality ng steam, malalaman mo yung mga ibang properties niya. Okay? Tulad ng S3. Okay? Paano natin malalaman yung S3? So, sa inyong Thermo 2, malalaman mo sa equation na, or Thermo 1 pala, na-discuss na to, SF3 plus X3 SFG3. Okay? I hope matandaan nyo yung equation na yan. Now, paano malalaman yung SF3? SFG3. So, yung SF3 ay yan yung SF at state 3, that is 60 degrees C. Saan makukuha yan? Makukuha yan sa steam table. Ito yung steam table natin. Okay? So, ito yung saturated. Okay? Tapos, hanapin mo yung 60 degrees Celsius. So, dapat gumamit ka ng ruler para hindi ka maduling. Yan, sa 60, hopefully makikita ninyo, sa 60, meron kang SF na 0.8313. Tapos meron kang SFG na 7.0769. Okay? So, sulat natin. So, ang SF ay 0.8313. Tapos ang SFG, okay, at 3, nasa 60 din yan, na-rate natin kanina, 7.0769. Tapos gamitin na natin tong equation na to. So, meron kang S3 ay 0.8313. Okay. Check ko lang. Tama. Plus, ano yung X mo? Yon 0.891. Okay. Multiplied by ito. 7.7 or 7.0769. So, ang S3 mo ay nasa 7.1368. Okay. So, mayroon ka ng S3. Okay na yan. Okay. Now, lagay ko lang dito. So, meron ka ng S3. So, balik tayo sa state 2. Okay. So, again, meron kang T2, 350 degrees Celsius. Kaya unknown yung P2. S2 equals S3 at lumalabas na 7.1368. Okay? Now, para malaman mo yung P2, dapat alam mo muna kung ano yung phase ng state 2. Anong phase? Ito yung kung liquid nga ba siya, kung vapor, saturated liquid, saturated vapor, or wet mixture. Paano natin malalaman yon? Hanapin mo yung SG at 350 degrees Celsius. Okay, hanapin natin. Punta ko ulit sa steam table. Okay. Tapos hanapin mo yung 350. Yan. 350. Okay, hanapin yung 350. Yan, hopefully makikita. 350. Lumalabas na ang SG at 350 degrees Celsius ay nasa 5.2114. Okay. Sige. Now, kapag yung SG ay ng 350 ay 5 ito yung saturated niya. Kung titignan ninyo, drawing ko lang yung TS diagram. Okay. Yan. Ito ay yung 0.3. S3 is 7.1368. Okay, yan yung S3. Ngayon, pagdating dito sa 350 degrees C, lumalabas na ang SG mo ay mas mababa. Ito yun, di ba? Ang SG mo ay mas mababa sa, exaggerate natin. Yan. Ito yung 7, ito yon. Kasi ito yung S, ito yung T. At ang SG mo dito ay, ito yung SG. Yan yon. Pero, ang point natin, ang point 2 natin ay nandito. Sure tayo na nandyan. Kasi nga parehas sila doon. Okay? So, ibig sabihin nun, superheated yan. Or, you could say that kapag yung S2 ay greater than SG at that temperature, therefore, superheated. Okay? Bakit kailangan natin yan? Kasi kapag superheated, ibang table ang gagamitin mo. Kanina, ang table na ginamit natin is yung nasa saturated water. A-4. Ngayon, pang wet mixture lang to. Pupunta tayo ngayon sa superheated water. Table A-6. Ito yon. Okay? Tapos dito, so meron kang different pressures. Okay? Tapos different temperature. Mag-umpisa tayo dito, 350. For convenience, kasi walang 350 dito. Ayaw ko munang mag-interpolate. Wala ding 350 dito. Okay? Dito muna, 350. Tapos, ang aking SG ay 7.1368. Dapat hanap ako ng malapit dyan. Halimbawa, ito. Okay, 350. At the pressure is 1 megapascal. Okay? Ang kanyang S, wala nang SG, SF dito. Entropy na lang. Ang kanyang S ay 7.3029. So, yung ating kanina, 7.13. So, hindi siya tugma. Pagdating dito, sa 1.2 pressure, yan, bumababa, 7.21. Pero hindi pa rin siya sakto. Pagdating dito sa 1.4, ayun, 7.1379. Pero hindi sakto, dapat sakto tayo. Although malapit na, kaya lang sa subject natin dapat sakto. Okay? Again, meron kang sa pagkakaread ko, sabihin ko dito, temperature, then pressure, then entropy. At temperature of 350 at a pressure of 1.4 megapascal, ang entropy niya ay lumalabas na 7.1379. Ang hinahanap natin 350, ito yung P2, unknown, tapos 7.1368. Ngayon, pupunta ako sa pressure na 1.6. So, nandito siya sa baba. Okay? So, hanapin ko na, lumalabas na ang kanyang pressure sa 1.6 is 7.0713. So, yung given natin, ito, in between siya nito. Ang gagawin natin, interpolate para makuha yung pressure dyan. Paano mag-interpolate? Okay? So, may binigay akong video about this one or napag-aralan nyo to sa term 1 rather. So, ang gagawin ko lang ay start with P2. Yan. Sabihin ko ito ay P2 minus yung pressure na maliit, 1.4 divided by yung malaki, 1.6 minus 1.4 equals P2. P2 is 7.1368. Kulang ng space. Minus 1 ito. 7.1379 divided by 1.6 is 7.0713 minus 7.1379. So, pwede mo nang gamitin yung calculator mo. Okay. So, ganitong ginagawa ko equation. Yan. So, meron kang yung P gawin kong X minus 1.4. Then, you have 1.6 minus 1.4. Alan. 7.1368 minus 7.1379, 7.0713 minus 7.1379, then shift solve. Yan. Yun yung sagot. Hopefully, nakikita ninyo 1.4. Yung sagot natin ay 1.4. Kaya lang may decimal point tayo kasi hindi sakto. Kaya, sa klase natin, should be P2, it's 1.4033 megapascal. Yan yung sagot. Okay. So, yan. Saan na tayo? Yung efficiency is 46. Okay. Yung pressure is 1.4. Yan, hindi na siya nag-interpolate. So, next is yung work net output. So, yan. So, paano natin malalaman yung work net output? Okay. C. Work net. Ano nga ba yung work net? Now, ganito muna. Meron kang importante yung schematic diagram, kaya dapat matuto kayong gumawa ng schematic diagram. Kaya ito simple lang, kaya wala masyadong problema. Now, gawin kong system yung buong apat na device. Now, may pumapasok na heat dito, the Q in. Then, you have work ng turbine. Then, sa condenser, naglalabas ka ng heat. Sa compressor, nagpapasok ka ng work. Okay? Kapag steady state, sabihin na natin na energy in equals energy out. Okay? Yan yung steady state. Tapos, kapag yung change in potential energy and change in kinetic energy ay negligible or zero, okay, malalaman natin na ang energy in, energy out dyan ay you have Q in. So, papasok yan, Q in. Okay. Ano pang papasok? Yung work. Work compressor. Ano yung mga lalabas? Okay. Work ng turbine plus Q out. Okay. Now, meron kang Q in minus Q out equals work ng turbine minus work ng compressor. Ito, ang tawag dyan, work net. So, ang work net is Q in minus Q out. So, ganun lang naman siya. Yan. So, work net equals Q, kung minsan sinasabi na work added minus work rejected. Same din yan. In, added, out, rejected, they're the same. Now, sa ideal gas law, meron kang tinatawag na Q equals temperature, then the integral of ds. Or kapag ito ay gawin mong delta, T, S, exit, minus S, inlet. So, ganun lang naman yon. Yan. Pwede natin gamitin yan. Bakit natin gagamitin yan? Sige. So, malalaman natin ang QA ay, ito yon, QA. This is 1, 2, 3, 4. Ang temperature niyan, okay, dito, ang temperature ng 1 to 2 ay yung 350. So, T high. Then, ang kanyang exit entropy is S2 minus S1. Then, Q rejected, yung nandito siya, ayan yung O, yung temperature niya ay low. TL pala, minimum. So, this is palabas S4 minus, saglit lang, baka magkamali. Okay. Dito, dapat S4 minus S3. Kaya lang magne-negative siya. Tinake into account naman na natin yung negative sign dito. Kaya gawin na lang nating positive. Kaya magiging S3 minus S4. Okay? Yan yun. But S2 equals S3. And S1 equals S4. So, pwede nating sabihin na palitan to. Okay? Ito magiging 2, ito magiging 1. So, lumalabas from this equation, work net is QA, T high, S2 minus S1 minus T low, S S2 minus S1. Yan yun. So, work net now is T high minus T low multiplied by S2 minus S1. Ito, kung papansinin mo, itong part na to, okay, yan yun, di ba? Yan yung height niya. Itong part na to, ito yon. So, length times width, area. So, lalabas ng work net mo pala ay itong area na to. Yan yun. Okay. For Carnot cycle, ayan yun. Baka lumabas sa board exam. So, pag meron yan, pwede mo nang sabihin na work net. So, pwede po pang gawing absolute. Kapag difference, same value na siya, kaya no need. Ito ay 350 minus 60. Okay. 350 minus 60. Then you have S2. Meron na ba tayong S2? Meron na. Nasolve na natin. That is S3. Ang problema natin, wala tayong S1. So, ito yung problema, S1. Ngayon, paano natin masosolve yung S1? Yan. So, another computation ulit para sa S1. Yan. Oh, madami na. S1. Ito, S1 or S4. 4. Ngayon, pagpunta ko ng S1, yan. Pagpunta ko ng S1, wala akong masyadong given except for temperature. Yan. Pero ang S4, meron kang X4. Ito, X4. Qualitative steam, that is 0.1. So, mas magandang mag-solve ako sa state 4. Sa state 4, ang kanyang T4 ay 60 degrees Celsius. Ang kanyang X4 ay 0.1. Ngayon, hinahanap ko yung S1. At alam natin, S1 equals S4. So, hanapin ko yung S4. Ang S4 ay SF at 4 plus X4 SFG at 4. Okay. Yan yon. Now, nakita na natin kanina yung SF4 is actually SF at 60 degrees Celsius. G4 is SFG at 60 degrees Celsius. Meron na tayong value kanina. Nakita natin sa steam table. Okay? Nasa table A-4. Rating ko lang. Tapos punta ka sa 60 degrees Celsius. Yan yon. Sa 60 degrees Celsius, makikita mo yung value which is the same kanina sa 0.3. Okay? Ngayon, nalaman na natin na ang SF4 ay 0.8313. Ang SFG4 ay 7.769. So, masosolve na natin yung S4, that is 0.8313 plus 0.1. Ito yung pagkakaiba kanino sa S3. Then, 7.0769. So, meron kang S4 na 1.5390. Kapag meron kang S4, ito na yon. So, work net, TH minus T low, S2 minus S1. Take note, this is S1. So, meron kang 350 minus 60. Then, S2 is, anong S2 natin? S2 ay, yan, hahanapin ko tuloy. Asan na? Nalito na rin ako. Ayun. Okay. S2. Tama ba? Tama. 7.1368. Okay. Minus. Okay. S1 na 1.5390. So, yung work net mo ay, tignan nga natin kung tumutugma. 350 minus 60, 7.1368 minus 1.5390. One answer is 1623.362. Ito yun. Press ba? Yan. Yan yung sagot. Okay. So, meron kang work net. Anong kanyang unit? Ito ay Kelvin. Ito ay kilojoules per kilogram Kelvin. Sir, bakit Kelvin yan? Di ba Celsius? Pwede mong maglagay ng 273 plus 273 plus 273. Pagka-cancel out lang. Pero Kelvin talaga yan. Kaya ang unit is kilojoules per kilogram. Okay? Yun yun. Okay? That's it.